Example 6 on page 349 of our book. Solve the following exponential equation. So let's just jump right into this one here. We have part A, which is 4,096 equal to 8 to the 2x power. Now, one thing I try to use when I'm solving these problems here is I try to use the Bros rule as much as possible, all right? Rule number 2 in our properties of logarithm and exponents, which is if I can have the same base on both sides, then the solving is a lot easier. So 4,096, I think, is a power of 8, and I believe it is 8 to the 4th power. And so this problem has become really a Bros problem because we've got 8 on one side and 8 on the other side as our bases, and we've got 4 is equal to 2x, really, is what this has come down to. And then if I divide both sides by 2, I'm going to find that the answer is 2. Works great if we can do that, but what if there's no way in heck that the bases are ever going to be the same? And that's really what part B is about, where we have 6 times 4 to the power of 3x minus 2 is equal to 120. Once again, the first step we want to do is we want to get the item that has the exponent by itself. So this 6 needs to go. So we need to divide both sides by 6 to start this problem, so that this becomes 4 to the 3x minus 2 equals 20. Now we need to get this exponent out. We can't solve anything with the exponent there, so now we're going to log or natural log both sides. I like the natural log, and so I'm going to natural log both sides here. So this becomes 3x minus 2 times the natural log of 4 on the left side. The right-hand side has become the natural log of 20. Now what I can do is I can say, let's just get this 3x minus 2 by itself, so I can divide both sides by the natural log of 4. It is a multiplication that's happening, so we can go ahead and divide by it. And so now what we have is 3x minus 2 on the left equal to the natural log of 20 divided by the natural log of 4. We're going to bring this 2 to this side here, so now we have 3x equal to natural log of 20 divided by the natural log of 4 plus 2. And then finally we can divide both sides by 3 here, so that x is equal to the natural log of 20 divided by the natural log of 4 plus 2, and then all divided by 3. And thankfully our calculator is going to do most of the brunt work for us on this one here. So let's bring that one back into play, the calculator. Clear off anything that may still be lingering from any other past problems. And so let's start here. The natural log of 20. So natural log of 20, close parenthesis, divided by the natural log of 4. Again, close parenthesis. Let's go ahead and enter at this point so we can see what this total is, because now we're going to add 2 to it. So plus 2. Enter. Let's get that answer. And then finally, we're going to divide the whole thing by 3. And we're going to have our answer there, 1.3869. And for us, 1.387. 1.387. And it's checkable. We could go back to the original problem here if we really wanted to. We could say 3 times 1.387 minus 2 as a power of 4, then times 6, and we should get 120.